Hi, this is Michael Lepo with assignment 2. Um, First, I'm just going to show you that my program works and how it works. So I'll run my main class, play game, and first asks you to enter the number of plies you want to do, and I'm going to do 5 for right now. And then the AI makes the first move, and you can see A represents AI. Then I'll make a move. Okay, so that wasn't really a serious game, but the AI won 182 to 177. Let's look at the code now. Okay, this is my state class that I use to represent the game state. To represent each state, I use a two-dimensional integer array I call board, and then I have an array list of states to generate the children of each state, and then each state is associated with a move, and that's the column that the piece would be dropped at. It's the constructor um, and filling all the variables and instantiating the children or array list. Okay, this is the most important part of the class, and it creates an amount of children depending on the columns filled and the board size. So let's say you have a 9 by 9 board, it will generate, uh, for each state, it will generate 9 children unless some of the columns are filled. And if it's a human, it will generate, it will fill the board with ones, and if it's the AI, it will fill it with twos. And then I have this deep copy method, which is used just so my children aren't referencing the same board as their parent. And then I have a get board, so self-explanatory, and a view board, which is for the gameplay. Okay, this is my min-max class that has the min-max algorithm. Okay, so this is the most important part of the program, and basically the min-max first checks if the depth is 0 or if it's a leaf state, and if either one of those conditionals are met, then it evaluates the node and returns the value. And if it's not a leaf or the depth is not 0, then it checks if it wants to find max or wants to find min, and just makes a recursive call to min max with each child node of the current node, and subtracts 1 from the depth, and if it's max, then it wants min next, and if it's min, then it wants max next. And then the second most important part is the evaluate function, which evaluate calculates the score of each index, either -1 or -2 for human, and 1 or 2 for the AI, and then sums the board. And that will return the score for each node. And then this is called within the evaluate function, and it basically goes through the board and checks the score of each index by looking at all its neighbors. Yeah, it's kind of a mess of conditionals, but it works. And that's about it for the min-max class. Okay, finally I have my main class, which is called play game, and I have some static methods in here. One's for the human to move, which just uses the Java IO library to get the standard input from the human, and then it has another static method called make move, which drops the piece into the board. And then in my main method, I use the buffer reader again, so the user can input the number of plies they want, and then I have this two-dimensional array of zeros to represent the board. And then I instantiate a new state, which passes in the board, and then I create a min-max instantiated min-max class too. And then basically while I is less than 40, so there's 40 moves per game. The AI makes a move, and then the human makes a move, and then at the end of the game, it uses this utility function within min-max to calculate the score.